Okay, so we're going to continue with where we left off last week, and I think we got partly through sedimentary rocks. You guys can help me here a little bit where we left off. I think we're about with the sorting part, and I had pointed out that sorting is like a winnowing fan, right? Where people separate grain from chaff, and they do that by letting it blow in the wind. Well, that's not exactly how it works with rocks, right? Although you could have some really fine particles that could get blown loose from larger gravel-sized particles, and so there could be some sorting due to that. But you have some things in your book, the picture in there, and it's going to show you something a little bit like this. So here we have, show you on here, poorly sorted. And what do we mean when we say that these sediments are poorly sorted? Go ahead, Olivia. What are all together? You're right. All different sizes are together. Okay. So this has great big particles and little tiny particles and in between ones and so on. And then this is going all the way up to here where we say it's very well sorted, pretty uniform in size. And what's happened over time, as you can imagine, is if this were carried in a riverbed, for example, it's going to tumble along. And when the river slows down, the bigger stuff's going to settle out. And then the smaller stuff's going to get carried on. And then the next bigger ones are going to settle out and the smaller stuff moves on. Go ahead, Carmela.
How do they all become like the same size?
Well, because whatever's moving them only has so much ability to move, right? I mean, if the water's not moving very fast, it might only be able to move sand. But if it's moving faster, it might be able to move little pebbles that are 2 or 3 millimeters in diameter. And if it was moving faster than that, maybe it could move things that are 5 millimeters in diameter, right? So that's what it's saying. There's no conscious attempt to sort it. It just, whatever the force is that's moving it can either move it or it can't. And when it can no longer move it, it gets, what's the word, left behind? Deposited. It gets deposited. And then it also talks about during that process that Carmela was just asking about, what else is happening to these pieces? Look at these pieces, not the size of them, but the shape of them compared to these pieces. Go ahead, Callan. They're smoother. As we go across, they're getting smoother because just these diagrams, it's gotten tumbled along, and eventually, it's like some of you said before, it's like having them in a rock tumbler. It knocks the sharp edges off of them, and they become rounder and rounder with time. Okay. The next thing then, the next characteristic of sediments is angularity. And that angularity depends on those collisions. And that's how sharp the particles are. Who can tell me one of the rocks that we looked at on Friday where the main difference was how sharp the particles were? One of them had big round particles and the other one had jaggedy particles. I'll get them back out so we can look at them. If you want to look back in your notes, you can maybe come up with a name. But I'll show them to you up here. Let me dim this, maybe you can see a little bit better. So remember this one I had all outlined, how this is rounded right here. And then there's this other one where it was, you can't see it really well, but it's the pieces, these pieces are stuck together, but the pieces are rounded. These pieces are stuck together, but the pieces are jagged. Anybody remember what those two sedimentary rocks were? Jack?
Clay and sandstone.
Well, clay and sandstone are sedimentary rocks, but they've even got smaller pieces.
Limestone.
Look back in your notes, guys. See if you can find it. You have the names of them in there. This means it's a combination of things. combination of things. Trey?
Breccia is pebble-sized and sharp.
So that's this one, Breccia,
Conglomerate, pebble-sized and rounded.
rounded. The rounded one is conglomerate, and the jaggedy one is Breccia. So here's the list of sedimentary rocks that you'll be responsible for knowing. Breccia, sandstone, conglomerate, shale, fossiliferous limestone, chalk limestone, oolitic limestone, and bituminous coal. Go ahead.
Will we have to know how to identify them?
Yes. Yep. That's what we're talking about. You need to be able to pick out the important characteristics of them so you can identify them. I'll let you finish writing that list, and then I'm going to show them to you up here on the projector. Are we close? Okay. Let's see if maybe we need a light on, if that'll help. Okay, so I'm gonna show you one, and I want you to tell me the name of it. So this one, I'll just tell you that as I slide my finger over it, it's very smooth. It feels almost slick. Harper?
It's the clay one.
It is the clay one. Look in your notes and see what the clay one was.
I thought that's where, oh wait.
No, you wrote it down a different place. Not the list you just made.
I don't have my notes from Robert.
Okay, Kellen?
Shed.
Shale. You are right, though, Harper. It is the clay-sized particle one. Very slick. Okay. How about this one? If I rub my finger along it,
Sand. Sandstone. Chalk limestone.
chalk limestone, right? Look at my finger. Okay. That's chalk limestone. How about this one? It's got these little pieces of shell in it, right? Got these little pieces of shell. Fossiliferous limestone. Okay. Now this one can be a little confusing. We'll see if we can. Okay. You can see that it's got these little tiny round grains. All bunch of little tiny round grains. What's that one?
Sandstone. Blood.
Baby? Tiny round grains. Tiny round grains. Carmela? I thought maybe you knew. Go ahead, Presley. No? Go. Oolitic limestone. What did I tell you the prefix OO means? Like oocyte, oogenesis, eggs. That's right. So that's why it's named that way, because it's got these little tiny round grains like eggs. Okay? How about that one? What kind of coal, Jack?
Bituminous.
Right, bituminous coal. That's bituminous coal. And then this last one feels gritty. If I rub my finger over it, it feels really gritty. Brooke, that is sandstone. And then I'll go ahead and show you these other two. You can probably see them a little bit better on here than you could before. What's this one with rounded grains? Vivian? Rounded grain. That's conglomerate. And this one that's got more angular grains. You can see that the pieces are a little sharper. That's called breccia. That's right. Okay.
What about shale?
That was the first one I showed you. Remember the one that Harper said was slickery? Because it has clay. Okay. So the next thing then, guys, is something called stratification. So this means layers of sedimentary rock. Different ways that it forms into layers.
Will this be the hardest chapter this year?
Oh, I don't think so.
I talked to Jessica at grade and she said it's a science fair.
That's a thing.
When's that due?
Well, not for a while. The first thing you got to do is find a topic. Okay. So when sediments change, so that's, if you remember, I showed you before that cross section of Scottsbluff Monument, and you could see the different layers. Particularly, I was showing you how a layer of ash got laid down. But each time the type of sediment changes, the way that strata means layer, the way that it's layered looks different. Now, you're not going to be able to tell the difference in a clay layer on top of another clay layer. You're not going to be able to really see any difference in that. But if you have, for example, a layer of limestone that was laid down, and then you have a layer of clay that was laid down, and maybe something like out there in the Valley of the Gods, or the Valley of the Monuments, I should say, what's called I went from western Nebraska to Egypt there for a minute. But that layer of ash that goes across all of those things, Chimney Rock and Scottsbluff Monument and all of it. Okay, so the first feature is stratification, just layering. Then we have several other ones, cross beds, where because the crust is shifted, you have these sloping layers. And then there are graded beds, where this is kind of what I was talking to Carmela about before, where it sorts out bigger particles and then next smaller ones and next smaller ones. And you have this progression of very large sediments to much smaller sediments. And ripple marks are the effect of wind or water. Around here, you're probably most familiar with that if you've ever seen sand that's in a blowout in the sand hills. It'll get a ripply top on it. Any of you ever seen that? Where wind is blowing over a big open area of sand, and so it has these ridges in it, ripple marks. And then mud cracks are when a layer of sediment has dried out and actually causes fissures or cracks in it. So the next thing we're going to do, guys, we're going to look at a screen that has pictures of all these, and you need to identify which one is which. So don't blurt them out. I'll call on somebody, but I want you to look at these pictures and tell me which one is represented by which one's represented by which thing. Okay. Give you a little bit of time to finish writing here. Okay. Tony, you're going to get the first shot. So make sure you're looking at this list of descriptions and see which one fits here. So this picture right here, which of those descriptions fits this picture right here? Okay. And give us the definition of cross beds again. Yeah. So this is cross beds. So can everybody see enough detail there to see this layer is kind of sloped down to the left, and this one's sloped down to the right. And that's some kind of tectonic activity, right? Earthquake type stuff. By the way, in terms of current events, what region of the world just had a couple of major earthquakes? Brooke? Afghanistan. Yeah. So you need to be praying for them. That's a difficult thing anywhere. And a lot of times the people that are most affected are people who don't have very sturdy housing and all of that kind of stuff, because that's obviously more susceptible to damage. Okay. How about this one? Carmela, you want to try that one? That was this one. That's the one Tony just said. See how I'm moving the cursor here? Those are ripple marks. That's right. Those are ripple marks. Okay. Next one. Zelia. Which one of those fits this picture? Read the descriptions and see which one you think fits best. We're down to 3 choices. That was this one. That was this one. Graded beds, because Aaliyah, what kind of sediments are up here? How would you describe them? Big. And as you go from here into the background, big, smaller, smaller, smaller. You can see down into there. Okay, how about this one, Harper?
Mud cracks.
Those are mud cracks. And then Gianna, how about this one? Stratification, simply meaning layering. It's got obvious layers there. Okay, so a couple of other things that we have here then, as far as features, are fossils. We already looked at that we can see plant and animal remains that are preserved or replaced by sediment, rock. And then we have something called concretions. Have any of you ever seen a concretion? What's it say as an example down below there? Geode. How many of you have ever seen a geode before? Only a few of you? I bet when I show them to you, you'll say, oh, I didn't know that's what you call it. Okay. So I'll show you a couple of different ones. Go ahead and write that, and then I'll hand these around. Okay, so a geode, when minerals precipitate, there's a rock that has its insides are different. The insides of it are different. Excuse me? Okay. So let's take a look at that. So here's what it would look like if it weren't yet opened up. So you can see that it has these kind of seams where you can kind of see some glassy looking material. So it has that. Here you see it, another one of those seams. Okay. And for those of you that are in the later class, I'll leave these up on my desk so you can look at them or hand them around. The other ones I think we've already handed around. So here's what, if it's cut open, here's what it looks like. So it's got this kind of an opening inside, and then it's got these crystal forms inside, and here you see something on the outside that looks very much like that uncut one. Okay, so that's a geode, and then this other one shows how it's opened up and it's still got the lid with it. Right, so this is the part that was broken off the base. So those are geodes. Have any of you ever collected a geode or bought a geode at a gift shop or anything like that? Do you remember where you were?
In Colorado.
Okay. Yeah. Yep. They're pretty cool. They're a pretty unique thing.
How did they cut these open?
I don't know. But I know you can't do it with a chop saw with a metal blade, and I tried that once. And mostly just ruined the blade. I would think you could do it with like a tile saw. Any of you familiar with a wet saw or tile saw? No? Any of you ever seen somebody use a tile saw?
Yeah.
Has water running over it?
Oh, yeah.
Yeah. Anyway, so, or even if you've seen them maybe out on the interstate when they're cutting concrete to replace a patch, they'll have a great big concrete saw. Okay, something like that you could use to open that up. Okay, same cartoon. Same cartoon. I recognize that. So we're ready to move on to metamorphic. Go.
Can you go back to contact metamorphosis?
To what?
You
What?
didn't have to write that one.
I don't know what you're saying. I would. That was a jump ahead.
Oh.
Here's where you should be. Metamorphic are ones that have undergone a change as a result of heat, pressure, or chemical processes.
You have to write that?
Yeah, I mean, I think you might already have it, but that's kind of the overview, but we're starting that new section now.
Me too.
Heat, pressure, and chemical processes, okay? So some minerals change. They're actually, to morph, guys, the word morph means change, okay? Any of you, I know this is an old thing, but are you familiar with Power Rangers? Never heard of Power Rangers?
Yes.
What do they call them? What kind of Power Rangers?
There's so many different.
Mighty? You better heard of Mighty Morphin? They change. Just morph means to change. Okay, anyway, so some minerals can change into others. Those minerals can change shape or size or arrangement. They can develop banding and circulation of hot magma.
Can they change color?
Say it again.
Can they change color?
Yeah, they might change color a little bit. We'll look at what can happen. Their appearance can change fairly significantly, although there is some similarity between the the non-metamorphosed form and then what it becomes with metamorphosis. It can develop this banding. And the way that it changed, is going to depend on the conditions. Yes. Are we ready?
No.
No. It looks like you could peel it apart like you would and eat it. Perfect. Look at me and smile.
All right.
How did they get this to cut so smoothly?
This was some kind of I would say, some kind of a saw that's made for masonry or maybe even a wet saw. All right.
Wait, one more second.
You ready, Ileana? Or who said that?
Zalia said that.
Okay. So contact means just what it says. It means it's changed because something has touched it, actually in contact with it. And so that could be a vein of rock that's adjacent to rock that's actually melted. And if it's adjacent to that, it's going to get very hot, but not melt. If it melted and reformed, then we would say it formed a new kind of what rock? If it melts and rehardens. No.
It's the I one.
It is the I one. Igneous. That would be a new igneous rock. But if it doesn't melt, but it does get very maybe near melting point, and it causes the structure of it to change, that's what we would call contact metamorphism. And usually we'd be talking probably about heat. And an example of that would be that slate comes from shale. And we'll look at a number of relationships there, how those work. But they're oftentimes paired. So shale can metamorphose into slate. Bituminous coal can metamorphose into a different kind of coal that looks a lot shinier called anthracite coal. Limestone can metamorphose into marble. And so you have a number of these things that are kind of paired.
Do I need to get a bus? Oh, okay.
So that's contact metamorphism if it's actually just that, touching. Then we can have something called regional metamorphism. And regional metamorphism is the product of maybe an entire area being affected by that, or perhaps a big area getting buried. And so that whole section undergoes a tremendous change in pressure. Yes? Does Ileana have it?
No, she can get that.
Okay. All right. Okay. Let's take a look just briefly at that. At that picture, and it's showing that picture in your book is showing how you can have this magma area, and then that area that's shown kind of in brown is showing how around the edge of that, the rock doesn't actually melt, but it does get hot enough that it can cause the structure of that adjacent area to change.
Can you stay there?
Yep, this is it. We're gonna quit with that, guys. Your assignment for tomorrow is page 11. Don't put your stuff away. You've got plenty of time to work. But your assignment for tomorrow is page 11. It's the vocabulary puzzle. So work on that quietly. If you have questions, ones you can't find, certainly come in and ask. Go ahead, Carmela.
Can we work as a partner?
No. We're going to work independently right now. Okay? So if you have questions, you can come up here.